July 19th, 1912. Just after sunset in northeastern Arizona, people look up. A brilliant fireball streaks across the sky. Not a star, not a plane. Planes don't exist yet in 1912. Something else, something extraordinary, brighter than the full moon. Visible across much of Arizona and neighboring states. Crossing the evening sky so fast that in seconds it's gone. Then comes the sound, an explosion, so loud that some people think a dynamite magazine has detonated nearby. Windows rattle, horses panic, people run outside to see what's happened. Then something more extraordinary happens. Rocks begin falling from the sky. Not one rock, not a handful, hundreds, thousands, meteorites raining down across the Arizona desert. Some striking rooftops, others burying themselves in the sand, falling across an area miles wide. Miraculously, no one is killed. What the people of Holbrook witnessed on that July evening was one of the largest meteorite showers in recorded history, one of the few times humans have watched an asteroid break apart overhead and scattered its remains across the Earth. I'm Keith Conrad, and this is Sidequests. Today, Holbrook, a small Arizona town, an extraordinary sky event, and what a shower of space rocks from 1912 still teaches us about our place in the solar system. Holbrook, Arizona. In 1912 is a small railroad and ranching community in northeastern Arizona, population of just a few thousand. Life is quiet, predictable. People work. Ranchers herd cattle. The railroad brings commerce and connection to the outside world. It's a frontier town, still relatively new, still establishing itself. Then on the evening of July 19th, the sky changes. Witnesses describe something intensely bright crossing the evening sky. Not a normal astronomical phenomenon, something unusual, something that demands attention. What they're seeing will be discussed and studied for more than a century. To understand what happened over Holbrook, we need to understand what's happening in space. An asteroid, a small rocky body orbiting the sun, crosses Earth's orbital path. For billions of years, it's been traveling through space, orbiting undisturbed, but now its trajectory intersects with Earth's orbit. And more importantly, Earth is in the way. The asteroid enters Earth's atmosphere at tremendous speed, tens of thousands of miles per hour. Now, something remarkable happens. People often think meteorites burn because they're on fire. That's not quite right. The intense heat comes from something else, compression. The meteorite is moving so fast that it compresses the air in front of it. The air gets crushed. Compressed air heats up just like when you pump a bicycle tire, the pump gets hot. The air in front of the meteorite reaches extreme temperatures, becomes plasma, a superheated gas. That's what creates the brilliant fireball. That's what makes it visible across hundreds of miles. But the atmosphere is working against the meteorite. The pressure becomes too great. The meteoroid, the space rock, can't withstand the stress. It breaks apart, shatters in a violent airburst high above the desert. Thousands of fragments scatter. Some continue falling toward the ground. Others are slowed significantly by their descent through the atmosphere, and the explosion creates sonic booms. Multiple explosions, shockwaves traveling across the desert. That's the loud sound people hear seconds after the fireball passes. It's a spectacular display, a cosmic event unfolding above Arizona. As the fragments fall, residents of Holbrook and the surrounding area watch in amazement. Rocks begin hitting the ground, small rocks mostly. Pebbles, dark stones with a black crust on the outside. A fusion crust formed by the intense heat of atmospheric entry. They fall across a wide area, roughly 6 miles long and 2 miles wide, though estimates vary. Over the years, as people search the desert and as scientists conduct expeditions, more than 14,000 meteorites are recovered from the Holbrook Fall. 14,000 separate pieces of rock from space and scattered across the Arizona desert on one summer evening. The meteorites are classified as ordinary chondrites, a type of meteorite that forms very early in solar system history. What makes them extraordinary? They're essentially time capsules. These rocks formed about 4.5 billion years ago. Before Earth itself was fully assembled, they've been orbiting the sun unchanged for billions of years. By studying them, scientists learn about the earliest history of the solar system, about what the sun's neighborhood was like in its infancy. about the materials that came together to form planets, including Earth. These simple black rocks are windows into cosmic history. Here's what's remarkable about the Holbrook meteorite fall. Nobody was killed. If you watch Hollywood movies about meteorites and asteroids, you see extinction-level impacts, massive explosions, devastation.
This is the Earth at a time when the dinosaurs roamed a lush and fertile planet. A piece of rock just 6 miles wide changed all that. It hit with the force of 10,000 nuclear weapons. 1 trillion tons of dirt and rock hurtled into the atmosphere, creating a suffocating blanket of dust the sun was powerless to penetrate for 1,000 years. It happened before. It will happen again. It's just a question of when.
The reality of most meteorites is very different. First, most incoming space rocks are small. Very small. Pebbles and rocks, not mountains. Second, Earth's atmosphere is a shield, a powerful shield. When meteoroids enter the atmosphere at extreme speeds, the friction with the air slows them down. The atmosphere destroys most of them, burns them up completely, turns them into meteors, shooting stars that people see and forget about seconds later. By the time meteorite fragments reach the ground, they've been slowed dramatically. The smaller pieces arrive at relatively modest speeds. The Holbrook meteorites, by the time they hit the ground, weren't traveling at cosmic speeds anymore. They were traveling at speeds fast enough to bury themselves in the sand, fast enough to strike rooftops, but not fast enough to cause serious injuries. Meteorites do occasionally damage property. There's one famous case of a meteorite striking a woman in Alabama in 1954. She was bruised but survived. Documented meteorite injuries are extraordinarily rare, rarer than being struck by lightning. The Holbrook shower was spectacular. Thousands of meteorites falling from the sky, but relatively harmless. 114 years later, the Holbrook meteorite shower is still scientifically important. Why? Because it's one of the best documented meteorite falls in history. Numerous eyewitnesses, freshly recovered specimens collected shortly after the fall, fragments that were uncontaminated by Earth's environment for more than a century. That matters for science. It means researchers can study material that hasn't been altered by weathering, haven't been contaminated by Earth's geology. Holbrook meteorites are now found in research collections and museums around the world. They're still being analyzed using techniques that didn't exist in 1912. Modern scientists can use spectroscopy to analyze their chemical composition, can use radioactive dating to determine their age, can study their structure at microscopic levels. Every analysis provides new information about solar system history. The Holbrook meteorite shower reminds us of something we often forget. Earth is constantly interacting with the rest of the solar system. Every day, tons of extraterrestrial material enters our atmosphere: rocks, dust, particles of ancient asteroids. Most of it burns up unnoticed. Creates shooting stars that people see and forget about, but once in a great while, once in a century or more, something special happens. The sky drops souvenirs. The Holbrook meteorite shower reminds us that the boundary between Earth and space isn't as sharp as we sometimes imagine. Our planet orbits through a solar system still filled with debris left over from its formation. Asteroids, meteoroids, comets, countless small objects still traveling their ancient paths around the sun. Most of the time they miss us, pass by harmlessly, but Earth is a large target. Our atmosphere is constantly intercepting material from space. Those small black stones that fell on Holbrook in 1912 had been traveling through space for billions of years, orbiting the sun, existing in the vacuum, unchanged since the solar system was young. Then on one particular July evening, their trajectory crossed Earth's orbit. Earth was there, the collision was inevitable, and people looked up and watched as the sky showered them with material from the birth of the solar system. The people of Holbrook probably thought they were witnessing a once-in-a-lifetime spectacle. They were. A meteorite shower of that magnitude is rare. Very rare. Most people live their entire lives without seeing anything like it. But what they witnessed was also something universal. Something that connects us to the cosmos. Something that reminds us that we're not isolated on Earth. We're part of a solar system, part of a galaxy, part of a universe in constant motion. Material from that universe is constantly arriving at our doorstep. Mostly invisible, mostly burning up as shooting stars. But occasionally, very occasionally, it's spectacular. Occasionally the sky drops rocks from space. In 1912, the Holbrook meteorite shower was a mystery to most people. A phenomenon without explanation, a miraculous event. Over the following decades, science provided explanations, understood the physics, explained how asteroids break apart in the atmosphere, how fragments fall to Earth. The mystery was solved, but the wonder remains. More than a century later, we understand the science of meteorites. We know how they form. We know why they fall. We know what they're made of. But when you hold a meteorite in your hand, one of those black stones from Holbrook or any other meteorite, you're holding something that has traveled billions of miles, something that has existed for billions of years, something that came from the birth of our solar system. That's not less wonderful because we understand the science. It's more wonderful because now we understand what we're holding. July 19th, 1912. A small Arizona town, an extraordinary sky event, a fireball brighter than the full moon, an explosion loud enough to be heard for miles, thousands of meteorites falling from the sky, rocks from space, fragments of asteroids that had been traveling through the solar system since its formation, finally arriving at Earth. 114 years later, those rocks are still teaching us, still providing information about solar system history, still reminding us that we're connected to the cosmos. The Holbrook meteorite shower was spectacular, but it was also ordinary in the sense that it's just one of countless interactions between Earth and the rest of the solar system. Every day, tons of extraterrestrial material enters our atmosphere. Every day, the boundary between Earth and space is crossed by material from beyond. Most of it is invisible. Most of it becomes shooting stars. Most of it leaves no trace. But once in a great while, something special happens. The sky drops souvenirs, and for a moment, we're reminded that the universe is not separate from us. We're part of it.